Welcome in France. Welcome to your G-Class off-road and on-road experience today. My name is Toni. I'm the head of product management of the G-Class, and together with my dear colleagues from Graz, because they are actually the guys who were engineering this great car right here. So maybe you just introduce yourself for a second.
For a second.
I need a minute at least.
Okay. My name is Ralf. I'm head of the drivetrain development in Graz. So responsible for all this you can see here, electric axles, battery, but also for the combustion engine development.
And my name is Andreas Limberger. I'm head of the overall functional vehicle team. We are responsible for durability, for passive safety, corrosion protection, and so on.
So, and before we start into technical details and before we show you actually the beautiful piece over here so that you understand how the electric G-Class works and how we can accelerate this car on-road and off-road, I would like to give you a very short overview of what we did when it came to the very new G-Class generation for 2024. And what you can see here is basically our 3 pillars when it came to the strategy. And this is not just a sales and marketing slide, it's really the core of the G-Class. And most and foremost, of course, we would like to start with off-road, because off-road, as you can see here, and you will experience exactly this trail today. So you have the possibility to drive this car off-road and also the combustion ones in areas like this. So off-roading is key when it comes to G-Class production and G-Class engineering. So there are basically 3 major ingredients for producing a G-Class. First is this here, so a very robust leather frame. This robust leather frame we already used since 1979. Of course, we had to adjust this frame several times to move with times and with technology, but as you can see here, also for the all-electric G-Class, we are still using this very robust and stiff off-road capable leather type frame. Second, low range reduction, so a mechanical low range gear for driving off-road for maximum of torque and performance, and that one also makes it quite easy to steer and to adjust the acceleration when you go off-road, and you can really climb up hills like with an inclination of 100%, and therefore we are using low range reduction also for the electric one, but more details from my colleagues in a minute. And third one, diff locks, differential locks. So with a regular combustion G-Class, we have the possibility to lock the rear axle, the front axle, and also the differential here in the center of the car. And by doing this, we make sure that all 4 wheels turn with the same speed, so there is no slip and we don't lose traction or torque on one of the on one of the 4 wheels. Of course, when you talk about 4 electric motors in this car, we had to rethink that concept. But how we did this, my colleagues will also explain, because there we are talking about virtual diff locks. So no mechanical components anymore, but a lot of intelligence behind. That's actually, in a nutshell, what is important for off-roading. Then let's come to the second pillar. It's unlimited, and unlimited in 2 ways. First of all, we now offer our customers the broadest powertrain portfolio of all times. So what we do here is we still have our G450 diesel. We now call it 450. Before it was the 400. Now it's the 450 because it's even more performant. The power increase in this engine is the biggest delta we have. So it's 27 kilowatt on top performance. That's the reason why it's kind of repositioned G450D. Then our all new G500. Now it's an inline 6. Before we had a V8 engine. Now it's inline 6. And of course, for all V8 enthusiasts and fans, we still offer G63 AMG. You will drive all of them today, on-road and off-road. So I'm looking forward to your feedback. What do you think about those amazing combustion engines? And then, of course, the new hero in this room, G580 with the Q technology for electric motors, all electric, as number 4 in the powertrain portfolio. And if we want to have a closer look here, you will see that we didn't just electrify the all-electric G-Class, we also electrified our combustion engines, because we are using the Mercedes-Benz mild hybrid system. So we have a 48-volt battery pack in the back of the car right here for all of our 3 combustion versions. And what we did here, you can see it pretty good with the G63 engine right here. We have our gasoline engine, our combustion engine, have an additional electric motor, and then we go straight into our 9-gear transmission. So in between transmission and combustion, we have this electric motor, and this electric motor gives us an additional power of 15 kilowatt or 20 horsepower and 200 Newton meter for boosting and accelerating. And the same values or figures you will find right here. So also for the 6-cylinder G500 and for the 6-cylinder 450D, we are using exactly the same technology, and all of them have the same plus in regards of torque and performance. It's not all about performance, it's also about efficiency. So especially if we talk about combustion engines like the G500, we came down with around 2.5 liters from for 100 kilometers. So that's really a big topic, because now it's really possible to drive this G500 with around 11 liters in real driving conditions. Before, with the V8, it took you around 13 to 14 liter on 100 kilometers, so that's really a big delta we achieved there. And still, all those engines have more performance and power and acceleration than the V8s that we offered before. But now, as you can see here, in terms of performance and also in terms of Newton meter torque, 4 electric motors do a great job. And how they work, we will show you in a minute. I said unlimited in 2 ways. The one is the powertrain portfolio, the other one is manufacture, means individualization for the G-Class. But what this means in detail, we will talk about this right before dinner tonight, so we prepared some information there for you. So just to make sure that unlimitation and a lot of possibilities to spec your car to make your G-Class your very unique and personal one, this is what we want to achieve with the manufacture program. And last slide from my side. Off-road Unlimited, established 1979. What you can see here, we have a car from 1979 compared to a very new G-Class 2024 production. The cool thing is, this could be a G450 diesel, a G500, or electric one, because you get all of them with the regular radiator grill. So all of them look pretty much the same. And of course, it was important for us that we stick to our very iconic shape, because this is why people love the G-Class. It's boxy design. The round headlamps, the indicators up here, the grab handle, the door handle, the iconic spare wheel on the back. So all those details in terms of design elements, they are very important. So also for the all-electric version, we stick to this very heritage design of the G-Class. But now we had the clear task to electrify this one some years ago. And the result and how we did this, I would like to hand over now to Ralf and to Andreas, and they will go with you into detail in terms of powertrain solution.
Yeah, let's get back to a few years back. How did we start the development of the electric G-Class? So for us, it was completely clear there's one major goal, and this major goal, you can read here, no compromises on off-road capabilities. So what does this mean in more detail? So it's clear, slope climbing ability must be 100%. So 100% is also there for the combustion engine, and there was no discussion that it can be less at an electric vehicle, it must be 100%. So that's 55 degrees. Right, so secondly, the weighting depth. The weighting depth is 850 millimeters. This is even 10 millimeters more as the combustion engine versions. Yeah? And by the way, this is that high. Right? So everything you can see here can be underwater, and it still works. So thirdly, Toni mentioned already, we have these differential locks in the combustion engine version. We don't need the mechanical differential locks anymore, because we have one motor at each wheel. So then it's easy, right? You can do the torque vectoring approach, so then you can just have the right torque at each wheel, so you don't need mechanically any connection anymore. So you can do it by software, right? So this is the main topics when we started the development in 2017 or 18. So, okay, so what were now the main components we have to develop? First things first is the axle. The axle means, in this case, there's the electric motor already included. So that's the axle, that's the electric motor. It's, as I explained, it's 4 motors. Each motor has a power of 108 kilowatts, which sums up to 432 kilowatts. So this is a pretty powerful car. It's even 2 kilowatts more than the AMG G53, right? So this is really powerful. And of course, we have the torque we mentioned before. We have more than 1,100 millimeters of torque. That's also really pretty much. So most important for the off-road capabilities is the 2-gear gearbox. So usually electromotors have 1 gear. Right, you don't need to shift stick or whatever. And in this case, we have 2 gears, 2-speed gearbox, and 1 gear. So the high range gear is for on-road driving. So this is optimized for on-road, so we can drive really. You will see this, you will experience this. You can really drive quickly with a lot of torque, with a lot of power on road. And in off-road, you don't need a high speed, right? So if you go to really hard off-road, you don't need to drive 180 or so. This is completely not possible if you go to hard off-road, but you need much more torque. And therefore, we have the low-range gear, and so with the low-range gear, maximum speed is 85 as far as I know it's 85 kilometers per hour, but torque is much higher than in high range. So then we have this charging system, and which in most of the electric cars we have two different kinds of charging systems. One is AC charging, which can you at home, for example, in the wall box, and this is 11 kilowatts, and this is the 11 kilowatt AC charging box over here. And if you go on highways and so on, you need to charge quickly and a lot of energy in a short period of time. We have the DC charging, and DC charging is with up to 200 kilowatts. So this is the inlet where you plug in, right? And then either you go to the AC box, and then this makes AC current to DC current, and then you go to the battery over here, or you go with DC directly to the battery. So, and then we have a lot, as I explained before, as we have 4 motors, each wheel has a motor, we need to control the motors, the torque, the power, even the energy flow and the cooling. And for this, we have the brain of the electric G-class, that's a computer more or less, or several computers, and they have to work together. So this is really super important. And last but not least, we have here the high voltage battery. That's this big black part, right? So this is all the battery. Power in the battery is 100, not the power, the energy in the battery is 116 kilowatt hours usable. Yeah? And now this is very special. If you have seen automotive battery already, they are super wide. Yeah? And in this case, because of the off-road capabilities, we still wanted to use the leather frame. It's not possible to have just an EQS battery or whatever in the car, because they are wide like this, and we have only space like this. So this is a special space or special housing for this battery. It's narrow but high, so we have 2 layers of cells in the battery. This is also unique at Mercedes-Benz. And for wading, it must be waterproofed, right? As I told you before, so the water can be high like this, and then the complete battery is underwater. Wow, crazy! And this is one of the reasons why we have for example, such a rigid lid. This is aluminium die-cast. There's no battery on the world which has an aluminium die-cast lid. Yeah? This is usually some kind of metal, 1-2 millimeters, but this is really rigid. Yeah? The reason is tightness for weighting, and another reason is, of course, with off-road, if you go off-road, it must be really stiff, right? And if you have just a regular housing, this is not stiff enough. What does this mean for the full vehicle? Andreas will explain in a minute. So, as I told you before, the capacity of the battery is 160 kilowatt hours, and of course everybody discussed what is the maximum charging power. It's 200 kilowatt, but more important is how much time do you need to charge the battery from 10 to 80% SOC, and this is 32 minutes in this battery, and this is honestly speaking pretty good because we have so big battery. 116 kilowatt hours is not a regular battery. This battery input, along with all the other components, leads to a range of 473 kilometers at WLTP. Okay, so what does this mean in off-road? In off-road it means, I don't know whether you know the Schöppel. Schöppel is a mountain close to Graz where we have really harsh off-road terrains. With this battery you can climb the Schöppel 14 times. This means, if you sum it up, it's 9,000 meters, even higher than Mount Everest, and you don't need to charge. Yeah, you can climb it for 14 times. Really crazy. And so now how this battery is working along with the frame for all this off-road stuff. Andreas,
thank you, Ralf. Well, as Ralf told, we have a really stiff battery pack combined with the leather frame. That's not enough. We have a third part that's underneath the battery. It's a protection plate which protects the battery in the off-road driving. So whenever you touch the ground, it will keep all the forces away from the battery pack. But also, it will give additional stiffness to the leather frame and battery pack system. So that's important for the tightness when you have the twisting of the car in the off-road driving, but also it helps you to avoid any noises from the interior in the off-road driving. Well, the protection plate is made of carbon fiber and a mix of some intelligent materials. You could also even take a material like metal, but this has a weight of 57 kilograms. If you take the metal, instead of the carbon fiber, it will weigh 3 times more. So that's quite an important fact to save the weight and also to have the stiffness and save place between the battery and the plate. So when you pack 3 G classes on the plate and the plate to a small stone, it will never touch the battery. So that's really a stiff plate. And to see how is the testing of our battery, we developed a special test bench, especially for the battery, to build up every single you will have an off-road driving test. In the twisting, there are all additional forces and also the weighting. Why the weighting? The battery has a different temperature than the water. The water in most cases is much colder than the battery, and so when the battery is shocked in the cold water, the air or the water will be sucked in there. And so you can test the tightness in a special situation with twisting and the differential of the temperatures. We will switch to the electricity system. Energy is coming in there, to the loading system, to the battery, and then to the motors. And the output will tell you now how the motor is filled up.
You explain this and this. But you can come over.
Oh yeah?
So this part you can see here is just the motors you can see here in the car, and we have here the model of this motor. So the energy comes in here. This is it's going in there. So this is this part. So and then the energy goes to the inverter. That's an inverter because that's DC current, right? But the motors, they need AC current. So and this nice box is creating AC current out of DC current. And the most important part of this, it's not really super well visible, but this is this white part. This is a MOSFET which converts the DC to AC, and that's high-end stuff, honestly speaking, because the efficiency of this inverter is 99%. That's crazy for a converter, right? So this is really latest technology benchmark, and this is mostly done by this MOSFET here, right? So we come in with DC current and we go out with AC, and bring this directly to the motor. So this is, this is only 2, but we have 3 because we have 3 phases, right? And we go down to the motor over here, and this is the motor. Of course, this is cut off, right? So usually you cannot see the motor, and this can be turned. So if there's power supply, then you can turn the motor. So then this motor, what we have explained before, goes to this gearbox, and then if you turn the motor, if you come over, you turn this motor. This shaft is also turning, and this shaft is going here directly to the wheel. So this part goes directly over here, and now we have this gearbox. This means then we turn the motor here 11 times. This is the high range. The wheel turns once, right? So and this is done by this gearbox.
11 to 1.
11 to 1 ratio, exactly. So that's the 11 to 1 ratio. And now we have a really, let's say, unique design, because this is motor number 1. And if you go here to this area, you can see here motor number 2. So each wheel has its own motor, and if I turn this motor, then you can see that this one here is turning. Right? Same, 11 times here in the motor, once here at the wheel. And this is a little bit, if you know engineering, it's a little bit a strange design, honestly speaking. Yeah. So it's very narrow. We have these 2 motors. The motors are here and here, but the axle is of course in one line. So why did we do stuff like this? Because engineers are crazy? No, this is not crazy. Maybe they are crazy, but as you can see here, we have not that much space. It's very narrow. And why is it so narrow? Because of the off-road capability of the car, we need the leather frame to do hard off-roading, right? So this is very narrow. And because in a regular, if you would have space, and the space would not be a restriction, then here's the wheel, and here's the wheel, and then we would have placed the motors just there in one line. But not possible because we are so small, so narrow due to the leather frame. So this is one axis, 2 motors, 1 motor for each wheel. Okay, this is one main message. And in high range, if you turn the motor once, the wheel 11 times, the wheel turns once, right? So, and now we have 2 gears, because when we go off-road, we need more torque. So, as you probably know, electromotors, they deliver huge torque values, right? But if you have low rounds per minute, because you are driving slowly, and you need a lot of torque, what happens when you climb a steep hill, right? And you need then this torque for a longer period of time. In a regular car, you need torque to accelerate. 0 to 100 in 4, 5, 6 seconds, and then it's over. Then you don't need the torque anymore. If you climb this hill, and you will do this later, you need the torque for 10 minutes, half an hour, whatever. So therefore, if you would provide this torque in the high range gear, this would become far too warm, and then you would then the torque would go down, and then you cannot climb the hill anymore. So therefore, we have the second gear. Second gear is we go here. These are the 2 gears. Yeah, this is now the high range, and then if you shift to this, then we have low range. And then again, if you turn the motor once, the wheel turns 21 times, the wheel turns once, right? So then you have a huge torque. So maximum speed is 85, and then you can have this huge torque forever until the battery is empty. You can climb any hill, right? No thermal issues anymore, because you have a completely different current, half the current, right? So therefore the thermal losses are much less. So, but they are not zero, of course. And this is one of the other things you can see here. In the housing we have these parts, and water with some kind of that, so that if you get below 0 degrees, so it's a cooling system of this part. This is water, and in this directly in the motor and in the gearbox we have oil cooling. Right, so this makes sure that the thermal management is always all right. Yeah. So now again, 2 motors at each axis, 1 motor for each wheel, then 2 gears. Yeah, and a good thermal system. This thermal system is also special in the G class. Usually, you put an additional part in this, but we had no space. What we explained before. So we put all these parts directly in the housing. It's die casted. It's really special. So but it's complex, yeah, and it's not that easy to produce. But you need less space, and the efficiency of cooling is much higher. So this is the motor. But now we have one more benefit. As we have 2 gears, we also can switch the gearbox to neutral. And if you can switch the gearbox to neutral, the motor stops and the wheel is just like it's just running. Yeah. So what can we do? We can decouple the front axle. So if we don't need a lot of power, not a lot of torque, we are just driving 100 kilometers per hour on the autobahn, we can switch off the front axle. What does this mean? The power consumption will go down. So in WLTP, we reduce the power consumption by 5%. On the autobahn, for example, highway, up to 10%. So up to 10% less power consumption by decoupling the front axle. It's really, really high-end super technique, yeah, because now if you push the pedal, you want to have the power again, right? As soon as possible. Now, if you drive 180, for example, or 160, this motor, the rounds per minute is 14,000 roughly. Yeah. So in the rear axle, front axle 0, and then you need power again. Then you need immediately you have to go to this high rounds per minute again, 14,000. You have to synchronize the gearbox and provide the torque here. Now guess how much time does we need from 0 rounds per minute to 14,000 to synchronize the gearbox and to provide the torque at the wheel if we want to.
I guess less than half a second.
Less than half a second, not bad. What do you think, guys?
No idea.
No ideas. Also
shoot,
good.
like two decimals, like 1.
It's 0.3 seconds.
Yeah.
So you're an expert. 0.3. 0.3 seconds.
Yeah.
Do we need to couple in again? And next big thing is you don't recognize it as a driver. You don't feel it.
How much weight has the motor?
The motor itself.
Yeah. Or just the rotor of the motor.
Just rotor. Sorry.
Because of the mass, you have to accelerate.
What you mean, but I'm the big boss, you know. I don't know all this.
No worries. No worries.
I don't know what's the exact weight.
Because that is crazy. In 300 milliseconds, from 0 to 14,000 rounds per minute is crazy.
Yeah, it's even quicker because we have to synchronize. In the 300 milliseconds, we still have to synchronize the gearbox. So because if you have different torques at different wheels, so it's for the whole process. 300 milliseconds. That's really wow. But for efficiency, it's crazy, right? 10% on highway, it's really good.
Yeah.
We have one more topic here. If you push the park button, right, we have in the front axle here a park lock system which just blocks the gearbox, and then the wheel cannot turn anymore. And this we can see here. That's the park box, the park lock system, which blocks the gearbox. It's here for this motor, and it's here for the front motor.
Yeah, it's
This is right here. It's not
this one here, this gear here, but it's locked from below, so it's hard
you
to
cannot
see.
see that well. That's hard here, and also so we have two hard locks for each motor. So,
But what is pretty cool, we don't have electricity now, but wait, I turn this one. Now you can hear it, and now
it's not that easy to
and now it's blocked and we cannot turn anymore. So this is
But the motors are turning now?
no, they are blocked.
So you could destroy the motor when you tow the car?
no, there's a system in there. So if the speed of the car is
Okay.
more than 3 kilometers per hour, it's not blocking the gear, and it's just not working.
Yeah, when all the systems are working. But when the 12-volt battery is dead
Yeah.
and the onboard system is dead,
And then
and you tow the car,
No.
you could destroy it.
no, no. There's some safety.
Okay. I trust you.
It's not happening. You can try if you
We have no tolerance.
so you can drive 20 or so and try to push the button. You will see nothing is going to.
Yeah.
Turn the other side around.
But good that you have the gloves not on, and you have.
Yeah, I have to wash my fingers right now.
Ausmachen.
Now we blocked because we are done with the motor, right?
Thank you. Thank you so much.
So if you have any questions, please.